71% of Earth's surface is covered in liquid water. That number is so familiar, it has stopped meaning anything. But consider what it actually implies. Earth formed 93 million miles from the Sun, inside what planetary scientists call the frost line, the boundary beyond which solar heat can no longer vaporize volatile compounds. Inside that line, water cannot exist in stable form during planetary formation. The heat is too intense. The solar wind strips light molecules before they can accumulate. Mercury formed inside the frost line. It has no water. Venus formed inside the frost line. Its surface temperature melts lead. Mars formed just at the edge, and it is a frozen desert with a shattered atmosphere and no liquid water on its surface today. Earth formed in the same neighborhood. By every law of planetary formation we understand, Earth should be as dry as Mercury. And yet, here we are, a world where oceans cover nearly 3/4 of the surface, where water falls from the sky, carves canyons, and fills basins 4 miles deep. More than that, Earth's water didn't just arrive once. The evidence shows it vanished, completely. Not once, but twice before the oceans we know came to exist. What brought it back is a story that cuts across asteroid impacts, mantle geology, and the chemistry of life itself, and parts of it are still being debated. Subscribe now. What comes next will rewrite what you thought you knew. Don't let the algorithm bury it. To understand how Earth got its water, you have to be willing to follow the evidence somewhere deeply counterintuitive. The story most of us carry, that Earth formed with its oceans, that water is simply part of what our planet is, doesn't survive contact with the actual data. The forensic record tells a different story. A story of a planet that started bone dry, was sterilized by a collision of almost incomprehensible violence, received water from a source scientists spent decades getting wrong, and then discovered, much later, that a second ocean had been hiding inside the planet the entire time. We are going to follow that forensic trail in sequence. We begin where Earth began, a molten, airless rock inside the frost line, with no water, no atmosphere, and no future that looked anything like today. We will move through the asteroid bombardments that seeded the surface, through the volcanic interior that hid its own ocean for 4 billion years, through the 10,000-year rain that built the first basins. And we will arrive at the chemistry of a molecule so strange that, without 2 of its properties, complex life on this planet would have been physically impossible. The first piece of evidence arrives immediately. And it is not encouraging for anyone who thought Earth's water was inevitable. Every drop of water Earth had during its first 50 million years was completely destroyed, vaporized, stripped, and lost to space. And the planet that exists today was built from scratch on top of a sterile, molten grave. That is not a metaphor. That is what the geological and isotopic record shows. In the earliest phase of solar system formation, Earth accumulated mass through a process called planetesimal accretion, small bodies of rock and metal colliding and merging under gravity over millions of years. Some of those early bodies did carry trace amounts of water, locked inside hydrated silicate minerals. For a brief window, infant Earth may have had a thin, volatile layer. Then, approximately 4.5 billion years ago, a Mars-sized body, which scientists have named Theia, struck the proto-Earth at an oblique angle with enough kinetic energy to partially vaporize both objects. The resulting debris disk eventually coalesced into the Moon. Consider what that impact meant for water. The energy released in the Theia collision was equivalent to billions of nuclear weapons detonating simultaneously across the entire planetary surface. The planet's surface temperature reached several thousand degrees Kelvin. Every volatile compound, water, carbon dioxide, nitrogen, ammonia, was either vaporized into a steam atmosphere that was then blown away by solar wind, or chemically broken down and incorporated into the magma ocean that covered the entire planet in the aftermath. There was no gradual cooling. There was no preservation. The slate was wiped completely clean. The Earth that emerged from the Theia impact was, in terms of surface water, identical to Mercury, a molten airless rock with no oceans, no water vapor, and no realistic internal mechanism to generate either at the scale we observe today. Stop and translate that into physical reality. The Pacific Ocean, the the largest single feature on Earth's surface, containing more water than all other oceans combined, did not exist in any form after that impact. Not as vapor, not as ice, not locked in rock. Gone. The question of where Earth's water came from is not an academic refinement of an otherwise settled story. It is a complete mystery about the origin of the defining characteristic of this planet. And the answer, when scientists began assembling the evidence in the 1990s, came from a direction almost no one had anticipated. The Late Heavy Bombardment began approximately 4 billion years ago and lasted for roughly 300 million years. It was triggered by a gravitational reshuffling of the outer solar system, Jupiter and Saturn migrating into resonant orbits, destabilizing the asteroid belt and the Kuiper belt beyond Neptune, sending a sustained storm of rocky and icy bodies raining into the inner planets. The cratered surface of the Moon, still visible today without a telescope, is largely a record of that bombardment. Earth received the same treatment, and because of its larger gravitational field, absorbed significantly more material. The obvious hypothesis was comets. Comets originate in the outer solar system, beyond the frost line. They are composed largely of ice. They arrive in the inner solar system in large numbers during the Late Heavy Bombardment. The logic appeared airtight. Comets delivered Earth's water. The logic was wrong. In 2014, the European Space Agency's Rosetta mission rendezvoused with comet 67P/Churyumov-Gerasimenko and measured the ratio of deuterium, a heavy isotope of hydrogen, to ordinary hydrogen in its water. That ratio, called the D/H ratio, is a chemical fingerprint. Every water source in the solar system has its own. Earth's oceans have a specific D/H ratio that has been measured with precision. Comet 67P's DH ratio was more than twice that of Earth's oceans. Not close, not within a margin of error, double. Other comets measured by prior missions showed similar mismatches. Comets, as a primary source of Earth's water, were ruled out by direct chemical evidence. The real delivery vehicle was something less dramatic in appearance but far more chemically precise: carbonaceous chondrite meteorites. These are a class of asteroid originating from the outer asteroid belt, just beyond the frost line, where water can be chemically bound into silicate mineral structures rather than existing as free ice. When carbonaceous chondrites were analyzed, their D/H ratios matched Earth's oceans almost exactly. They carry water not as liquid or ice, but as hydroxyl groups locked inside their mineral lattice. Water that survives the heat of atmospheric entry because it is chemically incorporated into rock, not sitting on top of it. Imagine the volume involved. The total water content of Earth's oceans is approximately 1.335 billion cubic kilometers. Planetary scientists estimate that carbonaceous chondrite bombardment during the Late Heavy Bombardment could have delivered somewhere between 10 and 50% of that total. Hundreds of millions of cubic kilometers of water, arriving over 300 million years, locked inside rocks falling from the sky. That is a staggering delivery, but it is not enough to account for the full inventory. The math doesn't close. And when scientists examined where the remaining water might have come from, they found an answer buried 700 kilometers underground. In 2014, the same year Rosetta confirmed the comet hypothesis was wrong, a geologist at the University of Alberta named Graham Pearson was analyzing a diamond that had been recovered from a Brazilian mine. Diamonds form deep in the Earth's mantle and are brought to the surface by volcanic eruptions through structures called kimberlite pipes. They are, in geological terms, messages from the interior, samples of conditions at depths no drill has ever reached. Pearson's diamond was unusual. It contained an inclusion, a tiny trapped fragment of another mineral that had never been found in a surface sample before. The mineral was ringwoodite. Ringwoodite is a high-pressure polymorph of olivine, a form of silicate rock that only exists under the extreme pressures found in the transition zone between Earth's upper and lower mantle, between approximately 520 and 660 kilometers below the surface. It had been predicted theoretically and synthesized in laboratories, but no natural sample from that depth had ever been recovered. That alone would have made the discovery significant. But what made it extraordinary was something else entirely: The ringwoodite in Pearson's diamond was wet, not metaphorically, not as a trace contaminant. The mineral structure of the ringwoodite, the actual crystal lattice of the rock, contained water molecules chemically bound at a concentration of approximately 1.5% by weight. At first glance, that sounds trivial. It is not. Ringwoodite is estimated to make up a significant fraction of the rock in Earth's transition zone, a shell of the planet roughly 250 kilometers thick, wrapping the entire globe. If the ringwoodite throughout that zone is saturated at similar concentrations, the total water stored in that single layer of the mantle is estimated at approximately 3 times the combined volume of all of Earth's surface oceans. 3 times. The Pacific, the Atlantic, the Indian, the Arctic, the Southern. Every sea, every lake, every river, every ice sheet on the surface of this planet. And then 3 times that again, sitting inside the rock 700 kilometers below your feet, in a form that no instrument on the surface could detect until a diamond happened to carry a fragment of it upward over the course of millions of years. This was the second disappearance. Earth's water hadn't only been stripped by the Theia impact in the beginning. Over billions of years, plate tectonics had been pulling surface water back down into the mantle through subduction, the process by which oceanic plates dive beneath continental plates at the edges of tectonic boundaries. The water, instead of being destroyed, was absorbed into the mineral structure of mantle rock and stored in the transition zone, a second ocean built incrementally over geological time, invisible and unreachable. But the most unsettling part is still ahead. The mantle is not a static reservoir. It convects, moves in slow, churning currents driven by heat from Earth's core over time scales of millions of years. As mantle rock rises toward the surface in volcanic systems, pressure decreases, and the water locked in its mineral structure is released as steam. This process, called outgassing, has been operating continuously since Earth's interior began to cool, but it was most intense in the planet's early history, when the mantle was hotter and volcanic activity was dramatically more widespread than today. Beginning approximately 4 billion years ago and continuing for hundreds of millions of years, volcanic outgassing released enormous quantities of water vapor, carbon dioxide, nitrogen, and sulfur dioxide into what was then a thick, toxic proto-atmosphere. Earth's surface was still too hot for liquid water to exist. The steam simply accumulated overhead, building atmospheric pressure, trapping heat. Then the cooling began. As the surface temperature dropped below 374 degrees Celsius, the critical point at which water vapor can condense into liquid, the accumulated steam began to fall, not as gentle rain, as a relentless, planet-wide acidic deluge. The atmosphere at that time contained high concentrations of carbon dioxide and sulfur dioxide, which dissolved in the falling water to produce carbonic acid and sulfuric acid. This rain was corrosive enough to chemically attack bare rock on contact. It fell continuously, in what geologists estimate was an event lasting somewhere between 10,000 and a few million years, until the ocean basins filled and reached an equilibrium with the atmosphere. The oceans that formed were not blue, they were greenish, rich in dissolved iron which had leached from the fresh volcanic rock of the early crust. They were hot. They were acidic enough to dissolve minerals that are stable in today's seawater. And they were already doing something chemically crucial. The acidic rain, as it fell across the young continents, was stripping sodium, chloride, magnesium, calcium, and potassium from silicate rocks and carrying them in solution into the basins. This is the origin of ocean salinity, not a fixed property of seawater, but an accumulation built over geological time from the chemical weathering of continental crust. The irony here is considerable. The same acidic chemistry that made the early oceans hostile to most life, as we understand it, was simultaneously building the ionic complexity that modern marine biology depends on entirely. And the water cycle didn't stop moving. Plate tectonics continued subducting oceanic crust back into the mantle, carrying seawater with it. That subducted water, now stored in the mantle, now released by volcanism, now falling as rain, now flowing back into the ocean, established a planetary water cycle operating not just at the surface, but through the full depth of the Earth. Without water in the mantle acting as a lubricant for the movement of tectonic plates, the friction between plates would lock the system, volcanism would slow, the carbon cycle would collapse, the planet would cool, the atmosphere would thin, and the conditions for complex life would dissolve. Water is not incidental to plate tectonics. It is the mechanism that keeps the planetary engine running. There is one final layer to this story, and it operates not at the scale of planets, but at the scale of molecules. Water's ability to support complex life is not simply a matter of being liquid and abundant. It depends on two physical properties of the H2O molecule that are, in the context of chemistry, deeply anomalous. The first is hydrogen bonding. A water molecule consists of one oxygen atom bonded to two hydrogen atoms in a bent configuration. Because oxygen is strongly electronegative, it pulls electron density toward itself. The hydrogen atoms carry a slight positive charge, and the oxygen carries a slight negative charge. This creates a weak electrical attraction between adjacent water molecules, the hydrogen bond. These bonds are individually fragile, but collectively they give water a specific heat capacity far higher than almost any other common substance. Water absorbs and releases heat slowly. This is why coastal climates are milder than continental interiors. It is why the ocean acts as a planetary thermostat, absorbing solar energy in summer and releasing it in winter. Without this property, Earth's surface temperature would swing by hundreds of degrees between seasons, sterilizing the land surface. The second anomaly is more counterintuitive and more consequential. Ice floats. This seems unremarkable until you examine why. In almost every substance, the solid phase is denser than the liquid phase, because molecules in a solid are more tightly packed. Water behaves oppositely. As water freezes, the hydrogen bonds force the molecules into a rigid hexagonal lattice that is actually less dense than liquid water. Ice is approximately 9% less dense than the water it forms from, which is why it floats. Consider what happens in a world where ice sinks. In winter, surface ice would descend to the ocean floor. More ice would form at the surface and sink in turn. Over time, the deep ocean would accumulate a permanent layer of ice that the sun could never reach to melt. The oceans would freeze from the bottom up. Within a geologically short period, liquid water would cease to exist on the surface. No liquid water means no hydrological cycle, no weathering, no nutrient transport, no chemistry capable of supporting the metabolic processes of any organism more complex than certain extremophile bacteria. The fact that ice floats, a consequence of the hydrogen bond geometry of a molecule so simple it has only 3 atoms, is a physical prerequisite for the existence of every multicellular organism that has ever lived on this planet. Connect the chain now. Water arrived from beyond the frost line, locked inside asteroids, delivered during a 300 million year bombardment. A second reservoir formed inside the mantle over billions of years through subduction. Volcanic outgassing released it to the surface, where acidic rain built the salinity and mineral complexity of the early oceans. And the molecule itself, by accident of its electron geometry, has 2 properties without which none of what followed could have occurred. The delivery mechanism, the storage mechanism, the release mechanism, and the molecular structure all had to work in sequence for the outcome to be liquid oceans on a rocky planet inside the frost line. Any one of those steps failing would have produced a different world entirely. Here is what the evidence, assembled in full, actually says. Earth's water is not original. It was delivered by rock from beyond a boundary the planet itself could never cross. It was stored inside the planet in a reservoir that remained invisible for the entirety of human history. It was released through violence, volcanic, acidic, relentless, and shaped by chemistry into the medium that life eventually learned to depend on at every level of its organization. This was not a gentle process. It was a sequence of catastrophes, each of which could have terminated the outcome, and none of which were aimed at producing an ocean. What this reveals about us is not that we are chosen or protected. It is that we are a residue. The oceans are what is left after 4.5 billion years of planetary violence failed, repeatedly, to produce a dry rock. We are the exception that the evidence says should not exist. and we are made almost entirely of the thing that should not be here. The next time you stand at the edge of the ocean, you are standing at the surface of that entire sequence. The water at your feet left a star's accretion disk, survived inside an asteroid for 4 billion years, was swallowed by the mantle, was expelled by a volcano, fell as acid rain for 10,000 years, and arrived at the shore through a chain of accidents so specific that it has only happened once in this solar system. The ocean didn't wait for life. Life waited for the ocean. Every mystery we uncovered today leads somewhere deeper. Subscribe. The next investigation is already in progress.